So my name is Ron Evo. I'm the CTO of cPacket. In the last section we're going to cover is network observability for AI, right? So we try to show you what we think AI can bring into network observability in the previous section. Now we see all these humongous clusters being built by our customers, by some of our partners, and we're seeing things that for us seem interesting. You know, it's still on the technology from our perspective to be able to deliver it. It's not a product out there, but I think it's worthwhile to mention it, say that we're working on it. It also will close some of the loop that we started with. We started with electronic trading. We started with microbursts. We went to enterprise application, which is not so much sensitive to microbursts. It's sensitive more to latency and connections. And now we're seeing these humongous AIML clusters. And again, before we go to the problem itself, it's interesting to understand how they, at a very high level, they work, right? So these are deep neural networks. You have thousands of GPUs. You take your data, you spread them across all the GPUs. They can all happily run in parallel. That's the forward path, right? But once you finish with one layer, you have to exchange the weights between all these GPUs, right? So that's called a backward path. So if I look at the network, what you're going to see on the left-hand side, that's how the network looks like. So you're seeing the network busy, 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 very bursty, right? And then nothing happens because they do the calculation. And then they will exchange the weights again, and they will stop. So really the same type of problems that we've seen before are showing up again, in the sense that the network is very bursty. The algorithms there are a little different, right? They're using Rocky, so it's not going to cause packet drops, but it will extend the job completion time. So we see customers trying, and this is another pet peeve of mine, right? The area where we are operating was used to called NPM. Now everybody says observability. But to me, NPM never made sense, right? It's not an issue about network performance monitoring. If I have a performance problem, I just buy a bigger switch. Right? It's about the network health issue, right? Because I can build, 7 lanes. If there's something in the middle, that doesn't matter there are 7 lanes, right? The traffic is not going to flow. And that's what the network operation people have to deal with, right? Is how do I keep the network running? Doesn't matter how many lanes I have there. And actually, the more lanes I have, the harder the problem is, right? So this is, again, performance. They buy these humongous pipes. But if all the data is trying to exchange at the same time between all the GPUs, it doesn't really matter. You're going to have a bottleneck there. And while you're not going to draw packets because it's Rocky and it's not low latency switch, still the job completion time is going to get longer, and they don't really understand it. So the same thing that we talked about before, microburst is this magic word about buffer overrun or buffer overload, but just in a very short time, showing up again. And if you think about it at a very high level, right, if the enterprise data centers is a lot of loosely coupled applications with high tolerance for jitter, heterogeneous traffic, you get the exact opposite in the AI fabric. And for us, cPacket is good news because these are exactly the characteristics that we came from, which is electronic trading. And we're able to use the same IPs that we developed for electronic trading, again here. And again, this is just a graph that we were in one of the experiments we were running. Right on time. So in closing, so we really are about, I think the whole message we were trying to deliver, right, through this journey is that in the context of zero downtime enterprise, packets matter, precision, the right precision matters. Sometimes it's nanoseconds, sometimes milliseconds, sometimes it's more than that or microseconds. And you have to do it in performance, right? So you have to be able to do it 100 gigabits per second and higher, and you have to be able to do it on many locations in the network. You have to be able to do it in the cloud and on-prem. And that's essentially what we're trying to do as a company.
I have an overarching question, if I may. Do we still have time?
Yes.
Remington, again. Can you talk at all about any specific enhancements or capabilities that your product has around encrypted traffic and the ability to provide visibility or understanding into what's actually inside of encrypted traffic? Because obviously that's a lot of traffic depending on which direction you're looking. And for a lot of security related incidents, which I know isn't necessarily the focus in networking field day, it's going to be encrypted. So
Right. So in the so I'll start with what we do. So if it's a layer 2 encryption, such as MACsec, we actually are able to decrypt the packet. So in the packet broker, and now AWS is showing it up and so forth. So we are able to decrypt MACsec encrypted. So essentially, if nothing is there and you want to see something, then we can do MACsec. If things are running over VPN, we will tell you the VPN health, right? So we know how to decrypt, not decrypt, but understand that it's an ESP, understand the reconnect, and if you're missing packets, so you'll know your VPN tunnel. We did not want to introduce SSL decryption into the products. It's all, so we have partners, and in deployments we work with partners to do that. In the cloud, the equation is a little different, right? So there are more opportunities in the cloud to do that. We haven't done that yet. So the reason we don't want to add any more hardware to kind of offset the performance that we can guarantee. So that's why we haven't done it on-prem. In the cloud, it's a little different, but we haven't done that. So this is like HTTPS or SSL decryption.
But following up with that question, like with TLS 1.3, you're watching behavior notions, so you can at least tell, like, it looks like this sort of auth traffic, or it looks like this sort of, like, you can get some behavior characters out of the payload, even though it's not, you're not seeing raw data out of it, right?
So we certainly decode all the certificates and the, so client hello, server hello, we decode. So if you can see all the servers that are in compliance or not in compliance, right? If someone is using 1.2.
Do you do mapping for endpoints? You're like, yeah, we can recognize that's Office 365 going to that destination address, or it's this service, or we're going to Okta, or we're going to whatever. You can map that through, right?
Right. So exactly. So the labels we have, you can either give us application or location. These are two configurable labels. The other labels that we have is from the DNS.
Okay.
So we can label the IP based on the DNS or the HTTPS ncheck. So yes, we can, the same kind of what I showed you before, we can use HTTPS SNIs.
Right.
And we are working to get an APIs. With the cloud is a little easier, right? But with the other IPAM vendors, their APIs are not quite easy to work with. So, yeah, absolutely.
On the ease of deployment, is there
like an average time you can share, like how much time it takes to deploy?
I mean, people come up and running. So it depends how well they know before. So one of the challenges we see is, as Norm said, is when we work with NetOps people, many times before the pre-deployment is long, right? We give them run books and say, okay, this is what you did in on-prem. This is how it's going to look like, and this is how it's going to look at the cloud. Then they have to go to their cloud team. How do I do that? So I would say if everything is ready, within the same day, it will come up and running, right? So they need the account access, right? So there are many, many permissions and whatnot they need to know in advance, and we try and give them the run book to do that. But then, technically it's a few hours or less, but within a day, something is running, a sandbox or whatever environment.
Very helpful.
So just one point on the QR code that's in front of you, that's a 30-day trial on CStore V, so our virtualized packet capture. So if you want to play around and kick the tires with it, you're welcome to do that. For those watching on YouTube, many moons from now, at some point that will turn off and the trial will end. So, but for people who are watching now or live streaming or watching in the near term, this is 30 days. Just have at it, and if you want to extend it, give us a call.